Hi there, I'm Neil van Niekerk. We're in the studio today and I should explain the setup. We have an acoustic guitar here, a camera with a tilt-shift lens. This is what we're going to do today. We're going to work with a tilt-shift lens and I want to show you how we control depth of field along a plane with a tilt-shift lens. Now when photographing items or products which are not flat and we need the entire item in focus, we can rely on three methods. Number one, loads of depth of field with a small aperture, but there are some limitations with this. Then we can use focus stacking. Focus stacking is where you take sequential photographs of slices of your subject as the camera moves forward, either on a rail or as your lens refocuses in steps. These photographs are then compiled with software, and it's truly magical to see how it all comes together. All these slices with f8 depth of field come together as a sharp image. Then number three, tilt-shift lenses. And this is where the magic lies. If a subject has a lot happening in 3 dimensions, then our best option is focus stacking. But when an item is relatively flat, in other words, 2 dimensions, then working with a tilt-shift lens is great. And it's specifically, obviously, then the tilt option that we use. An example would be a building facade that veers away from our viewpoint. Another good example is when you photograph a landscape which has tremendous depth, but a breeze can cause movement in the scene that will be better photographed with a single image using a tilt-shift lens rather than multiple images using focus stacking, because that breeze will have leaves and tree branches moving, and that makes focus stacking perhaps a bit difficult. Now, before we discuss tilt-shift lenses, we need to delve into a little bit into the topic of depth of field. First of all, only the specific plane on which you focus is precisely sharp. The areas behind and the areas in front of the plane you focused on are progressively more and more out of focus as you move past that plane of focus. Those areas might appear sharp if you use a small aperture, but remember, only the plane you actually focused on is truly, truly, truly sharp. As you close the aperture of your lens, the out of focus areas look progressively sharper. And the reason for that is an involved explanation about the circles of confusion. I will link to a Wikipedia article if you really want to explore the science of that. There's a lot of math. Now, when you look at depth of field tables or the markings on your lens, because older lenses used to have depth of field markings, that depth of field table or that depth of field scale isn't an exact transition from sharp to not sharp. It's a gradual transition. And this is where the concept of circles of confusion come in. A weighty subject with a lot of math. Again, I'll have the link of the description in the video. So how are things like depth of field tables determined? And those depth of field markings in a lens? That's done by looking at an 8x10 or an 8x10 or A4 sized print from a 1 foot distance and then judging by eye if the specific portion of an image is sharp. If that sounds like a definition that's a little archaic, well, it is. The technology that we have now has surpassed the original assumptions of depth of field and what is constituted as sharp in an image. We now have 50 megapixels, 60 megapixels, 100 megapixel cameras within our reach, and large monitors on which we view these images. We don't rely on judging sharpness only by how it appears in an 8x12 or A4 size print. We now judge it by how it appears on a screen, a large screen. This also means that hyperfocal distance is a somewhat nebulous idea to some extent. Hyperfocal distance is where you focus at some point in the scene. There is some depth, some distance in your scene, and you hope that the small aperture will give you enough sharpness from front to back without you having to be specific about what you focus on. Great for street photography. You can go to f11, pre-focus in a certain distance, and just shoot without having to specifically focus. Again, there's a link to hyperfocal distance in the description. Okay, so where does this leave us? It leaves us with a notion that depth of field might not give us a sharp enough image if the thing that we are photographing has some depth to it. We can rack our lens to f22, but then we have another problem. Diffraction kicks in, leading to loss of sharpness. Our next option, focus stacking. This is brilliant, as I mentioned, but it can occasionally be unpredictable in how the software stitches the various slices together. Also, if you have a client there looking at this, you'll now have to explain to them, oh, don't worry about it, these 30 images will appear sharp. Now, my main objection to focus stacking is that if you are photographing multiple products for a client, this workflow can slow you down. And again, you have to reassure the client that, oh, the final image will be great. Now, a better option in many cases, and in my opinion, is a tilt-shift lens. And here we have the Scheimpflug Principle working in our favor. Yay, more math and geometry. I will link to the relevant Wikipedia article in the description. Now, the Scheimpflug rule says that if you have this plane of your subject and the plane of your sensor or film, where it intersects, and you take the halfway point in the angle, halfway, and that halfway point is where your front element of your lens is, your subject will be sharp front to back. And we'll show that at f2.8, this guitar fretboard from here to there will appear sharp at f2.8. And then we shoot at f8 or f11, and it's really sharp. So to explain all of this, as I said, we're going to photograph this guitar fretboard. And let's say we need to photograph this at an angle like this. Maybe the client wanted it like this. Okay, let me take it out of the tilty. We'll go straight on. And you'll see, obviously, we focus on the nut here. It's sharp. But as we go towards the bridge, it's hugely out of focus. Okay, so if we focus then obviously on the back, the front will now be out of focus. But Scheimpflug to the rescue. If I now tilt my lens at a certain angle, front to back will be sharp. So here's how we do it. We focus on the front part. That looks pretty sharp to me. Now, it is a bit of an iterative process here. So that's sharp, but how much have we tilted? We don't know yet. That's not sharp enough. So we are going to tilt it a bit more. And you can see there the nut is pretty sharp. But now we have to go back to the front. You might have to refocus. No, it's good. We got lucky. We didn't have to juggle around a little bit with it. So now, as you can see there, that front part is in focus. And the distant part is in focus at our viewing aperture, which is f2.8. The headstock here is tilted. That bit of a drop in depth of field there, we're going to take care of that with f11. It's a decent enough aperture. Diffraction won't be a problem. So let's take a photograph. Now, because I'm moving the camera, I set it to a self-timer that gives us 2 seconds. So I'm going to take the shot, let it go, and in 2 seconds the camera will have settled and we get sharp enough focus. So I am at, let's go 20th of a second. Just for the example here, we'll go 800 ISO, f11, that looks good. And just recheck the focus. Okay, and let's take the photograph. Now, if this seems a little laborious, it is perhaps for one photograph, but let's say you photograph specific items over and over, more or less the same size. They will all be in the same plane. You can just crank it out, conveyor belt, item after item after item, without having to stitch it all together in software with focus stacking. So anyway, very elegant way of doing it. Let me show the close-up of the lens to show you all the controls. The shift portion of the lens is where the lens is shifted up or down. This is very useful for correcting perspective if you do architectural real estate. Instead of tilting the lens up and getting the converging verticals and then having to fix it in post, you now point the lens straight forward, and then this little knobby on the other side, you can shift the lens up or down, and that will correct your verticals for you without you having to tilt the lens up. Really elegant. Looking at the lens from above again, if you need to shift the lens vertically, this little button here is now going to move the lens forward and back. Not useful. And then what we do is there's a little release here, a little knobby here, and we can rotate the lens. Let me show you again. You rotate the lens like that. And rotating at 90 degrees, this little control now will shift the lens down or up. Sorry, my hand is in the way. So that little knobby there, the lens shifts up or down, and this way you correct your perspective without having to tilt the lens up and fixing it in post. You do it in camera. So here's the knob with which you can swing the lens. In other words, you tilt the lens. So if we rotate this, the lens shifts down by a number of degrees, and then the lens tilts a number of degrees up. But let's say you shoot vertically, but you want the lens to swing from left to right still. There are little release buttons here with which you can rotate the lens. And now the lens swings left to right with a camera vertically. I hope that was a fascinating look into these interesting lenses. They just do stuff that other lenses don't do, and they're a lot of fun to use. Highly specialized. They're definitely the right tool for the right job in certain niches. Anyway, any questions, let me know in the comments. Thank you.